Oh, you saw that? Oh, crap. Okay. Well, hi. Hi. Didn't see you there. Hi, I'm Fitz. Welcome to the Boring Show. We're going to do another episode here, following up on Filip's from last time, where he was talking through a lot of just how to navigate the Flutter source code. And one of the interesting things that we landed on there was there's these native things at the very end. You navigate down the widget tree, you find some elements, you find some render objects, you get all the way down to where you're actually having to draw the pixels, draw the actual lines that show up around a box or something like that. And it's just this native call. And we saw that show up in a couple of different places. And so let's just recap a little bit through what that kind of looked like. Here's a simple app that I started with, and there's not much to it. If I scroll around, we just have our normal main app and a home page and a state. And we've got a row, it has a checkbox and a Flutter logo. Now, that's it. That's all it does. Really simple. Don't even have to run it because it's just a checkbox and the Flutter logo. So the checkbox is nice because it's a pretty simple widget. It's not like center where it just does a line, which is what Filip was showing last time. But it does have a box and it has some checks and it's a little bit more interesting. So what does that actually look like? Let's dive down into that and see how quickly we can get to some sort of native thing. So here's our checkbox with a stateful widget. And my goal is to try to determine what these native calls are doing and where they are coming from. So here's our checkbox. And we scroll down, we get through all the parameters. There's more parameters, lots of different parameters. We get through. Eventually, we should find, we're creating a render object. That's great, or at least finding a render object that we can base our own render object, the checkbox's own render object, off of. And let's see, we keep going down. The build method is kind of interesting because that's where we get all the theme data and figure everything out. We're just collecting a bunch of different settings. You know, we've got the size here. We've got what is our box constraint. Let's get our mouse cursor if we need one, if we need to maybe change it to a hand or something like that. We've got our states. We're just collecting a bunch of different settings for what our hover and things like that. As we go further down, we get to our return, which focusable action detector. That to me sounds like maybe there's some rendering there that could be interesting. But again, I'm trying to find something that where we can get to the actual native calls to drawing things on the screen. And so the focusable action detector doesn't really seem to me like it would be something that would do that. That seems more like a semantics sort of thing to me. And if we hover over that, we can briefly poke into it and see it's just a stateful widget that. So scroll down through. I just want to verify that this doesn't do anything interesting for this purpose of this. Oh yeah, it's just a mouse region. So that's going to handle things like trying to detect when the mouse is over the checkbox and things like that. So that's not going to draw anything necessarily. Maybe it does in the further down, but this checkbox render object is maybe likely going to have more of the actual drawing of things. And so let's see, let's go down as we go through. By the way, if you're new to navigating source code, I'm holding down Command on Mac and then clicking on the function names. You can do the same on Windows by holding down Control and clicking on the function names. This is in VS Code. IntelliJ has similar shortcuts. I don't remember what they are off the top of my head. But as we go down here, we see the render object that was found earlier show up again. But this time, we're actually having it be a render checkbox, which extends a render toggleable. That's cool. What does this render checkbox do? Well, we scroll down through, we get some values, so we need to know like what kind of, whether we're a check or an empty box, or the dash for the null case for the checkbox if we're in the three try state. And we go down, let's see, we've got a function that does some outer rectangles, some create paint stroke. That seems like a helper to me. Let's scroll further down. Oh, we're at the bottom. So this is really what I wanted. We have our paint function here, which is actually drawing the checkbox. And this is kind of nice, right? It's got, and this is how you might create your own widget. If you were trying to define your own design system and building it up from scratch. Like suppose you wanted to replicate an old operating system in Flutter and have all of the pixelated borders and really unaliased text and gray boxes and things like that. Then it's not based on any existing widget, so maybe you'll have to go down all the way to painting directly to a canvas, and that's what we've got here. On this checkbox, we have this render checkbox has a paint that's pulling in a canvas from the context and painting directly to it. And we can just look through this a little bit and see we've got our rectangle border defined. We've got our paint color defined. And then we can draw the border and then draw a rectangle and then draw some dashes and some checks based on our state. Seems pretty straightforward, but the question here that we're trying to get to is how do these actually get drawn? So let's look at the border and draw the border. Is this one interesting? Because we're calling into our canvas where we're drawing a shape, a draw dr rectangle, some sort of shape, almost but not quite entirely unlike, and that's funny. So if we go into that, this function is pretty simple. Doesn't do a whole lot. We make some assertions that the inner and outer are valid rectangles. And then we just go and call the same function. And then here we go. This is the interesting part where we're calling our native canvas and then some kind of draw function. Maybe we can look at even another really simple one, like the draw dash here. A dash is just, it's not a dash, but a line, a horizontal line. And let's see, if I draw a line within that draw canvas, that's also incredibly simple in the same way, where we have drawLine just asserts some things and then hands it straight off into the native canvas drawLine. Okay. One of my extensions has unexpectedly quit. That's okay, because we don't need it for finding through the canvas. So this is where Filip ended last time, where somewhere hidden in here is this native function. Because how do we draw a line? Well, we call the canvas drawLine. And then what does the canvas drawLine do? Oh, it calls the canvas drawLine. Huh. Okay. So for this, I happen to know that Flutter uses Skia for a lot of its rendering, for most of its rendering. And so the first thing that I tend to do is I'll head over to my favorite search engine, and I'm just going to look for the Skia documentation. I'm going to try to see if I can find the documentation for the canvas drawLine. So go into here, and there's lots of the canvas. Skia does a lot, but we're specifically looking for the canvas's drawLine. So let's take a look at SK canvas, and of course This is a very long document as I scroll very fast through it. But let's try to find our draw line. Aha, okay, we're getting somewhere. Here's our draw line. It's a documentation for our draw line. And again, it's a pretty simple function. So we have a draw, we draw a line segment from point 1 to point 0 or vice versa using these things. So it could be interesting to find these things maybe too. So we have a SK matrix that we could poke through. We have an SK paint, which we could poke through. Maybe that's going to tell us how we paint it. But these are starting to look a little bit similar to what shows up in our actual Dart code that we started from. We've got x1, y1. Well, what is a point in 2D space if not an xy coordinate? And then we have an x2, y2. So we've got 2 points here, and then we've got some paint data. So we're clearly doing something here to translate it from Dart into the native drawLine function. And so this bit that I've highlighted here, this sk canvas : drawLine, would indicate to me that it's some kind of C++ like thing with the name spacing of the double colon. So this is probably going to end up in some C++ code, which makes sense. We're calling out to native, and then what do you use to write native code? Well, C++ are kind of one of the defaults that you can go to. So there's no easy click on the button to find the source here. But you can kind of poke around a little bit and find Skia source, not course. Source code. Let's look for the Skia source code. So there's a handy mirror here of the Skia source code. And there's a bunch of stuff here. Fortunately, I've already cloned it out. And here down in my terminal, you should be able to see that I have actually cloned it, and maybe we can do a git pull just to make sure we're up to date. Great, we have our latest source code. And within the source directory under core is where all the interesting bits are in Skia. So I've already opened up skcanvas.cpp, so we have our C++ file there. And I claimed that we should be able to find sk canvas with a lowercase a draw line. Aha, okay. Ooh, interesting. Now, this is kind of neat. We've got, this is very similar to what we were seeing in the documentation for Skia as well, where we've got our x1, y1 and our x2, y2, just 0 index instead of 1 index. That's fine. And let's see, we create an array of points. We set point 0 to 0, point 1 to 1. I guess that's why we 0 indexed those variable names. I guess that makes sense. They're going into an array. And then we call a drawPoints. Okay. So we don't draw a line, we are drawing points along a line. That seems similar to something that like a DrawPath would do. So what do we got here? What is that? What does this K lines point mode come from? I'm not sure yet. Let's go into drawPoints. What does drawPoints do? Okay, so we have this point mode. Is our point mode documented in the source code at all? K lines point mode. Draw each pair of points as a line segment. Oh, so maybe we would do just draw a line straight up. I guess that makes sense that we'd have some kind of helper or shortcut for that. Okay, so our draw points, we have the mode, we have how many. It wouldn't be good C-like code if we didn't have some things hanging around that tell us how many of the stuff we want. And then we have our points. So from our, if I back out one more, from our drawLine, it was just a line segment of one point to the other one. So our points, so we're passing 2 points in. Oops, I don't have a bunch of Z's. Passing 2 points in via this points array, and then our paint object. So let's go into that. And then, trace event and then on DrawPoints. That sounds like an event-driven something or other to me. Interesting. If it's not already clear, I'm totally unfamiliar with Skia code. So this is an exploration for both of us, for all of us. Okay, so on DrawPoints. So we're like scheduling an event to happen, I guess that makes sense. We want to just schedule it on like the next time we're going to draw things. We don't want to draw it immediately necessarily because there's UI threads and stuff like that we need to worry about. So I guess it makes sense that we'd probably want to schedule it. So have an on DrawPoints, so when we're ready to do this thing, do this. And that's what this function is. So let's see, we do some asserts. Then if we're only doing 2, which we are, with our drawLine, we're only doing a line segment, so we only have 2 points to draw, so our count is 2. We're setting our bounds to the first one to the second one. Compute bounds from points. Okay, that comment seems redundant, but that's okay. Enforce paint style matching implicit behavior of DrawPoints. So we're saying, okay, we've got our paint we're got our stroke paint, setting our style to the stroke style. Internal quick reject. All base functions should call this during and skip drawing if it returns true. Let's see, internal quick reject. Oh, interesting. Okay, so it's saying if we're having to stop what we're doing, then just stop what you're doing. So don't actually try to draw this. So I'm guessing here, and I'm totally making things up. This could be completely wrong, but I'm guessing that this allows for instances where maybe we're partway through drawing something and we need to interrupt that and draw a completely new frame. Maybe the user clicked on a button while an animation was happening or something like that, where we're going to need to stop what we're doing. So maybe that's what this is doing. I don't know. Maybe someone who's more familiar with Skia can tell me. Okay, so then we've got this layer that we're working with, and this this top device, and then DrawPoints. Oh, we've got another DrawPoints that we can go to. Okay, so the on DrawPoints is basically just, if I'm reading this right, it looks like we are setting where we're pointing, setting how we're pointing, how we're painting, and then checking if we should paint. Not to be confused with should repaint from a custom painter in Flutter. This is Skia. It has its own terminology. So let's see. We have its top device. I don't know what that is. The topmost device in the stack. All drawing and clipping operations should route to this device. I don't know what a device is in Skia. Maybe we'll find out later. I want to look at this DrawPoints though. What does this DrawPoints do? Okay, so we've got our point mode again. Okay, that was the thing that we saw earlier that was talking about, briefly pop back into that to say that we were doing a line type, right? Because the way we got here, as a reminder, was from the drawLine function. So drawing points with the line mode, 2 of them hopefully still. If our parameter passing is happening appropriately, we've got 2 points in there and then our point paint. We're still just like calling the same method again and again, and just doing intermediate steps. So I guess we're doing some verification here, making sure that this, which is, our device. I guess that could be like the actual screen that we're painting to. Let's call it that until we learn something else. So let's see, we're seeing if it's empty clip, I guess meaning that we have no actual surface to draw on, then we'd return, if we don't have any points to draw, we return, didn't we already do that? Didn't we already check? We checked if it was less than or equal to 0. We did already check that. I guess it's just to be sure, we're checking again. Okay, that's fine. Why not double check whether our count is 0? So then SKT, I don't know what an SKT is. Copy on first write to the SK paint. Paint, clean paint, or source paint. A lot of painting there. Let's come back to that. That sounds like it's just some preparation, maybe maybe it's telling the underlying Skia system what paint we're using. I don't know. We'll figure that out later. I want to get through the full function and then we'll come back. Oh my gosh, there's more. Oh, there's so much. Okay, let's see. Where were we? Point mode does not equal. Okay, so we're checking if we're in point mode. We were not, right? We were in line mode. If we come back to DrawPoints, our mode is this. We were from drawLine, which is the lines point mode. Okay, so it's just this point mode thing, and we're using specifically the lines mode out of the point mode. Okay, makes sense. We're going into DrawPoints because we are drawing some points in a line mode, so we can skip this. We don't have to do that because we're doing lines, not points. And DrawPoints converts to multiple calls to device DrawPath. So I mentioned this earlier as a potential idea where, it's very similar to a DrawPath. We just happen to be drawing a very simple path, which is between 2 points. So it kind of makes sense to me that we'd reuse some of that logic. We only use this when there's a path effect because of the overhead of multiple calls to the setup content entry. Ooh, I like that comment. It says why we're doing something. So if paint.get path effect, which returns if the path effect is set. So I guess if we already have like a path that we're working with, then we can do that. Otherwise, I'm guessing we have to create our own. Do we eventually, I don't know what this all is doing, but do we eventually get to another DrawPoints down here? After we allocate some memories for some writers, assert a bunch of stuff. Yeah, that's a bunch of work. There's a stroke cap, move, close path. Oh yeah, we're definitely doing like our own path making here. Yeah, so we have our PDF utilities. I'm guessing that PDF means something other than portable document format. But that looks like a path to me. So we're saying start at 0, go to count divided by 2. I guess that works. Because we're moving from point 1 to point 2 and then going to the next one. Okay, so this seems to be like something's actually happening here. I'm curious. We had a shortcut up here if we already had a bunch of that work done. Curious if this DrawPoints does something really similar. So we get into this draw thing, which then draws points. We're still in our checking if count is 0. We're just making sure, absolutely making sure that count is 0. With some more asserts, this looks very similar. It's, well, sort of. Okay, we have another matrix That's fun. It showed up from the documentation, right? What our SK DrawPath drawLine was doing. Remember from the documentation, we had drawLine here, draw segments from P0 to P1 using the clip SK matrix and SK paint. So there's our SK matrix showing up here, where we're getting what that is. I wonder how it's used. So we're kind of meandering through the code, but that's okay. Oh, here's very similar to what we had before, just done in a totally different way. We're checking based on what our points mode is. And again, we are in lines point mode. I like lines. And so let's see, we're checking if our count is 2. Just verifying count. We are just absolutely making sure our count is exactly what we need it to be. And so we get our paint rectangle, we get our path effect. We're doing some point with the points data. Oh yeah, so this is definitely just using the SK path instead of doing whatever that PDF utils was doing. So we get our new path, which with our paint object, which is actually doing the painting, we are setting our points using that path, making sure that is set properly before we continue, and we have a new paint. Oh, and then in our device, we can draw a path with those points. And what do we do after that? Let's see. Okay, so we draw from our last point to the new point, as long as that's not empty. If our x is the same as the y, the rest of the dashed line. When did we get to a dashed line? How did that happen? I guess maybe there's some... Just draw as points. If point get path effect as points, maybe this as points thing tells us whether it's dashed or not. Let's take a brief detour into that. Oh, there's no documentation for it on it. Okay, we're gonna come back out of that. I'm guessing that might have something to do with this, but okay, well, we're telling us what kind of, whether we're doing rounded points or hard points, and then we're doing the same device draw points here. That's aside from the draw path. Getting lost in the C++ code. Let's take a look. I want to look at this draw path thing from the device. Yeah, because we have our device set. Oh, there's multiple places we could potentially go. SK draw. What is this doing? My eyes are glazing over all of the C++ code. Yeah, why not? Let's go into this one. So I guess it makes sense then that we have somewhere underneath the canvas draw line, we then have our draw path, because again, what is a line if not a path between 2 points? I wonder if we're going to verify count again in here. Do we even have a count that we could verify? No, maybe not. That's a bummer. I wanted to see count go all the way down. So let's see, get path effect, style, and okay, so is it mutable? Our path is changeable. Interesting. Some matrix providers. At this point, we're done with pre-path matrix. Yes, seems like a redundant comment. We have If pre-path matrix is, okay, well, maybe we're just saying we're done, except we use it here. Oh, that's a debug statement. Never mind, it's fine. Oh, here's that copy on first write thing again. So maybe this is going to show up similar to what was after. Remember, we came here from, there was a shortcut that said if we already have something ready, don't redo anything, just hand off to that. So the earlier one we saw from this was, I think, before that, or after that, rather. Okay. All right, so we have a new block. What does this block of code do? We are trying to determine the size and opacity of what we're painting. Yeah, set stroke width, set the alpha from this writable paint, which is our paint.writable. So our paint, that's coming from up here with our new paint object that was created. Okay. So we're just trying to get how big to draw the line. This feels like we're getting somewhere on how to draw this. And when our paint, let's see, we get our effect, style, getting the rectangle that we're supposed to draw in, get our clip bounds, and then we can fill the path. Compute rescale for stroking. Is that it? Ooh, draw dev path versus get fill path. Ooh, now we're getting into somewhere interesting. Okay, so one of the things, we'll take a brief aside and just talk for a moment. One of the things that rendering libraries need to do is at some point copy drawing instructions over to the GPU, whether it's an onboard GPU or an embedded GPU or a standalone GPU that's plugged into your PCIe or a slot or whatever. At some point, we need to copy those drawing instructions over to the thing that's actually going to draw. And so a lot of the code that we've just stepped through is trying to get up to that point, trying to get to this point where we can have these really definitive instructions that we send off to a GPU. And this is where the matrix stuff comes in, where the GPU says, give me a space of pixels and tell me what to do with those pixels. And what is a set of pixels if not a flat 2D surface? Then that sounds like a matrix to me, right? No matter if we're doing 2D drawing or 3D drawing or anything else, ultimately it shows up on our monitors. And the fact of monitors is that it's 2D. It's we only have a flat XY coordinate space to work in, and so we work with matrices. And this is part of why GPUs are also really popular in scientific computing now too, because there's so much matrix and vector calculations that happen in scientific computing. That's like mostly linear algebra when you get down to it. And what is linear algebra if not combining matrices in random and interesting ways? And so we use graphics processing units there as well. And so if we get back into the code, there's a lot of just preamble here, basically, like calculating what is our stroke width, how big is our line going to be, how many pixels wide should our line be, what is the effect? Are we drawing them or how are we drawing them, right? And so at some point down here, we get into this let's actually transform this into something that can really be drawn. That's where our matrix is starting to come in. There's multiples of these. Let's dive into this a little bit. We are transforming a matrix into a destination. So we have to get this destination memory to get to the device. Assert that the caller is not trying to do this in place, which would violate constness. Okay. Do not return false, though, so that they know what they're doing and want to violate if they can't. Okay, we have some flexibility on our constness then. All right, so we're doing some matrix math. Is it an identity matrix, which is ones along the diagonals. If it doesn't preserve, okay, this is bringing up old linear algebra stuff. If finite or empty, then there's nothing to do. At this point, we're guaranteed to succeed, so we can modify the destination. So our rectangle equals the new rectangle. Where did the new rectangle come from? We were mapping it from the one that we were given, right? F rectangle. Where did that come from? Where did my F rectangle come from? Okay, well, from somewhere. But I guess we combine those two to get me, that's just an empty rectangle potentially. So we can get our destination mapped with the new rectangle, which was based on our original matrix that was passed in. Okay, so we've got the type, only transform that we allowed is axis align. So the type remains unchanged. Where did our F type come from? I don't know. Okay. I guess this is some kind of class. We probably had it set as part of the path pointer here, which we set in our fill path, which we reset things and then guess we didn't set our type there, but maybe we could have. There's a default set that we're doing. It's only a line after all, so I imagine things are pretty simple. So if we're a type of rectangle, what sorts of types can we have? Rectangle, oval, simple, complex, last. I think we're probably going to be rectangle type, right? Did we set that anywhere? If we did it in oval, we did. Where is this one? 9 patch, I don't know what that is. Oh, now we're into the transform. Okay. All right. Well, so if we're a rect type, I'd imagine a line is a rectangle type, based not one of the other ones. But now we're just asserting that things are true, okay? Because we're not an oval. Okay. So I guess that means it's properly mapped onto the destination. Where was our destination come from? Dev path pointer. Possibly allocating a new path if we have to. Okay, so we saw earlier that the path is mutable is true. We get this path pointer, which we created from this stuff here, where we were setting our path effect and things like that. We also have an earlier one from the pre-path matrix. Okay, whew. All right, so we're still working with a path, but it's been transformed a couple of times. So we've got our point data and our what we need to draw defined into our dev path pointer here. And then we can finally get down to maybe using that to draw the path. And blitter. What is blitter? I have no idea what blitter is. Auto blitter choose. Okay. Whew. Man, as we get further down into this, so we do some more setting of things, and we process maybe. What do you do? Proc. Transform scanline proc. Turn f proc. Whew. Okay. Wow. Now we're getting really into the weeds here. So I think this is about where I'm going to call it. And just to summarize, the way we got here was to start right here from a checkbox. And like Filip did in the last episode, we just kind of dived into it, going to the definition of each one of these methods, clicking through to see what makes up these things. It's all based on open source, right? It's all there. So how do we find what there is? So we clicked through checkbox, we found some render checkboxes, and that led us to a native canvas_drawLine. And so what happened with that? Well, we had to go and search through Skia because our canvas drawing comes from Skia. And so diving into that, that leads us into a mess of matrices and copying things to devices and lots of validating that count equals 0. And so I hope this was somewhat useful for you to going through and that you learned some about how to dive through and read some of the Skia source code. So that'll finish out our episode for today. Thank you very much, everyone, for being with me, and we'll see you on the next one.